Today we will discuss elastic collision in center of mass frame of reference. That is again elastic collision in center of mass frame. In previous article we have discussed elastic collision in lab frame. Now it is the second case in which we will discuss elastic collision in center of mass frame. The same problem we will discuss, that is there are two particles, first particle of mass m1, second particle of mass m2, and first is moving with velocity u1 and second is moving second is at rest, that is u2 is 0, and it will strike to the second particle, and after striking the first particle will move along this side, that is with velocity v1 and mass is m1, and the second particle will move toward this side, mass m2 and velocity v2. So this is again the same diagram, but thus we will study this diagram with a different point of view, that is we will discuss it with the center of mass frame. We know that what is center of mass? Center of mass of two particles is lying at any point where the whole mass of two bodies is supposed to be concentrated. So let the center of mass of these two particles is lying at this position. This is center of mass, because this is first particle, second particle, and net mass is lying at center. When it is moving toward this side, as it is moving nearer to the second particle, the center of mass will slowly move also towards the second particle, because what is center of mass? It is mostly the first particle, second particle, and center of mass is here. When the first particle is reaching here and second particle is again at the same position, and the center of mass is lying along this at this point. Similarly, when first particle is moving because it is reaching at this point, and second particle again is at rest, it is at the same position, and center of mass is like here. It means center of mass is moving with slow speed as that of the first particle. So in this case, before collision, the center of mass is also moving, but its velocity is different than the velocity of first particle. So what is the velocity of this center of mass? The center of mass we will study. So first of all, we will study the velocity of center of mass. So we have already discussed that the velocity of center of mass is equal to mass of first particle, mass of second particle, that is m1 u1 plus m2 u2 over m1 plus m2. So this formula we have already studied in the previous article in the center of mass case. So this is the velocity of center of mass before collision. This is before collision, and this equation number 1, it is used for before collision. But after collision, so what will happen after collision? After collision, the first particle is moving along this side, second particle moving along this side. Initially both particles they are at these positions, and the center of mass is lying here, and after some time particles are moving with different speed, and center of mass will move along this side. It means the motion of center of mass, if you observe only center of mass, then with the movement of first and second particle, the center of mass of these two particle system is also moving. So what will be the velocity of the center of mass? That velocity is, the velocity is v dash. So what is v dash? V dash is m1 v1 plus m2 v2 m2 v2. So here these are u1 u2. U means before collision the velocities of both particles, and v1 v2 are the velocities of first and second particle after collision, and the formula is again this. So these are two formulae which shows the velocity of center of mass. So before starting the overall elastic collision, we will study the velocity of center of mass initially. So, these are the velocities of center of mass, because in center of mass frame we have to aware about the center of mass. What is center of mass, where it is going, with what velocity it is moving, and these are the velocities of center of mass before collision and after collision. So, as from the diagram, the second particle is at rest before collision, that is u2 is 0. So, V become m1 u1 over m1 plus m2, and the second remains same. So, this is second equation, and the first equation is this, because u2 is 0. And also we know that according to law of conservation of linear momentum, we have a single equation, that is m1 u1 is equal to m1 v1 plus m2 v2. This equation we have already discussed, and when we put this value m1 v1 plus m2 v2 is equal to m1 u1, so this will become m1 u1. So, it means the both velocities become same, both velocities are same. So, this implies v is equal to v dash. So, it is very much clear that the center of mass is always moving with constant velocity, and hence it is also proved from this formula that velocity of center of mass before collision is equal to velocity of center of mass after collision. So, this is the expression for velocity of center of mass, but our aim is to discuss elastic collision. So, before discussing the elastic collision, we have to discuss this velocity of center of mass. Now, let the velocities of these particles are u1 dash, u2 dash, v1 dash and v2 dash in center of mass frame. So, I have taken the velocity of these particles. The first particle is moving with velocity actually u1, but it is with respect to lab frame, but in center of mass frame the velocity of first particle is u1 dash, and second particle is at rest in lab frame, but the second particle is also in motion according to center of mass frame, and similarly v1 dash and v2 dash. The first particle moving with velocity v1, but it is in lab frame, but as we study in center of mass frame, the velocity of the first particle is v1 dash and second particle is v2 dash. So, these velocities are entirely different as compared to the velocities of the particles in lab frame. So, let we have supposed that these are the velocities of particles in center of mass frame. Now, what is the relation between velocity of first particle in center of mass frame and the velocity of first particle in lab frame? So, we know that we will use the concept of relative velocity. We will use the concept of relative velocity. What is relative velocity? The velocity of particle in dash frame is equal to u1 minus v. So, this is the equation, because center of mass is moving with velocity v and u1 dash is the velocity of first particle in center of mass frame and u1 is the velocity of particle in lab frame. So, this is the equation which correlate the velocities of first particle in lab frame as well as in center of mass frame with respect to velocity of center of mass itself. So, this is the first equation. Similarly, u2 dash is equal to u2 minus v and v1 dash is equal to v1 minus v and v2 dash is equal to v2 minus v. So, these v velocity of center of mass, this may be written as v dash, but in magnitude you know that v and v dash both are same. So, these are the velocity of center of mass. These are the velocity of particle in lab frame. These are the velocity of particles in center of mass frame. So, this is a set of 4 equations which correlate the velocity of particles in both center of mass frame as well as in lab frame. So, we may find the expression for u1 dash. What is u1 dash? It is equal to u1 minus v. So, what is u1? Here u1 dash is equal to u1 minus v. So, what is v? It is u1 minus v. So, what is v? We have already proved v is m1 u1 over m1 plus m2. So, I have studied in the previous lecture this one, and on taking the LCM and solving it, it will become m1 plus m2 is equal to is m1 u1 minus m2 u1 this one, and minus m1 u1. So, m1 u1 will cancel out and remaining term is m2 u1 over m1 plus m2, it is u1 dash. So, this is basically the velocity of first particle in CM frame, center of mass frame, in terms of lab frame. Similarly, you can find the relation of u2 dash with u2 and v2 dash v1 dash with v1 and v2 dash with v2. So, by putting the values of v in the previous 4 equations. So, I have solved the first equation. Similarly, you can find second, third and fourth. So, these are the velocities of all the particles before collision and after collision in center of mass frame as well as in lab frame. Now, finally we will find the momentum, because we know that the collision is elastic. As we know that the collision is elastic, so therefore, both momentum and kinetic energy remain conserved. You know that this is a condition for elastic collision. So, first of all, as momentum is conserved, so we have to find the momentum of these two particles before collision and momentum of these two particles after collision, and similarly for kinetic energy. So, what will be the momentum of first particle? Momentum of first particle is m1 u1 dash. Momentum of second particle is m2 u2 dash. Momentum of first particle after collision. So, these are the set of momenta for before collision, and it is for after collision, v1 dash, and it is m2 and v2 dash. So, these are the formula for momenta of first and second particle before collision and first and second particle for after collision in center of mass frame. So, you may put the value of u1 dash, u2 dash, v1 dash and v2 dash here and find the values for momenta. So, on solving all these values, you will find that the momentum of two particles before collision is always 0. So, you will find that m1 u1 dash plus m2 u2 dash is equal to 0, and similarly the sum of these two particles after collision m2 v2 dash is 0. So, these results will be found on solving, on putting these values, and we will get these answers. The net momentum before collision is 0 and net momentum after collision is 0 in center of mass frame. And second one, we also know that the kinetic energy is also conserved. It means the equation for kinetic energy half m1 u1 dash square plus half m2 u2 dash square is equal to half m1 v1 dash square plus half m2 v2 dash square. This is the equation for kinetic energy. So, again on putting the values of u1 dash, u2 dash, v1 dash and v2 dash, which we have already discussed, on putting these values, and we will finally find that u1 dash is equal to v1 dash. So, you may solve it by yourself, and u2 dash is v2 dash. These results will be obtained on putting the values of all these velocities in this equation, in the equation of kinetic energy. So, these will be the answer, that is velocity of first particle before collision is equal to velocity of the first particle after collision, and velocity of second particle before collision is equal to velocity of second particle after collision. So, the velocities remain same when it is observed in center of mass frame, but it is not true in lab frame. So, you have observed that in lab frame first particle is moving, second is at rest, and after collision first particle moving with v1 velocity, second with v2 velocity, with different velocities. But in center of mass frame it is obvious that the velocity of first particle before and after collision are same, before and after collision of second particle is also same. So, these type of results we have observed in center of mass frame. So, the diagram is same, the event is same, but our point of view is different. That is, we are observing this event with the center of mass frame. So, this is the difference for the observer with respect to the observer. So, this is the article for elastic collision in center of mass frame. Thank you very much.